/craft.
The information economy has arrived. The world is teeming with innovation as new business models reinvent every industry. InsideAnalysis is your source of information and insight about how to make the most of this exciting new era. Learn more at InsideAnalysis.com.
InsideAnalysis.com.
And now, here's your host, Eric Kavanaugh.
Oh, yes, indeed, folks. Welcome to the future. It is your host, Eric Kavanaugh. It's time for the only coast-to-coast radio show all about the information economy. It's called Inside Analysis. And today's topic, we're going to talk about a very common theme here on the show, analytics. We're going to talk about analytics and how it drives the information economy, both literally and figuratively, quite frankly. We're going to hear from a couple guests today, including Todd Blaschka of a company called TigerGraph and Soudip Roy Chowdhury of a company called Eugenie.ai, which came out of Fractal.ai, also a very cool company. We're going to talk about how analytics is used to literally run the information economy. You can get analytics lots of different ways. There are database technologies, there are machine learning technologies that are good at generating these kinds of insights. But as a general practice, what we're talking about is analyzing data, finding patterns in data, then getting insights from those patterns, and then doing something about it, closing the loop, as we say, closing the loop to where you can actually generate some business value from the analytics that you have derived. So to keep things topical, let's talk about one of the really interesting spaces that everyone knows a little bit about these days called supply chain, right? Supply chain management. It's pretty complex stuff when you get right down to it. You have millions of parts, millions and millions of different objects that get moved around. In many cases, they're needed for manufacturing. So you have to have lots of parts. We're watching some strange things happen on the US-Canada border right now, and that's causing some difficulty in part because there are lots of car parts in Canada that want to make their way to Detroit so they can make cars there. So that's causing some issues. But think of all the truckers too. If you get all these truckers forming convoys and not doing what they normally do, which is moving all of our stuff around, well, that's going to cause some problems as well to the supply chain and to your grocery stores. So a lot of this stuff doesn't matter until it stops working. And then everyone's like, wait, what's going on? Well, we'll talk about that today. So first, let's bring in Todd Blaschka from TigerGraph. I've known Todd for several years now. TigerGraph is a very interesting company that's built out enterprise graph capabilities. And if you want to know what a graph is, well, look at LinkedIn, look at Facebook, look at a lot of these social media companies have built their entire business models around graph. Think about 6 degrees of separation and the whole story with Kevin Bacon. In fact, that's the first example I ever got when someone tried to explain graph to me, is the whole story about Kevin Bacon. Every actor in Hollywood is, just 2 or 3 steps from Kevin Bacon. What you mean by steps is when you traverse a graph, when you create a graph and then start traversing it, you're going from point to point. A graph is made of nodes and edges, unlike a traditional database that's like rows and columns and various tables and things. A graph stores information on nodes, like a person could be a node, and an edge, which would be a relationship, like a movie that they were in, for example. And so if you go 2 or 3 steps, you're doing hops, as they call it. You're going, okay, here's Kevin Bacon. He started in this movie with John Voight, for example, and they started in this movie with some other person. You're using graph technology to kind of bounce around and understand the relationship between people or the relationship between things. And those relationships can be extremely valuable, especially if there's covariance, as we say. In other words, if one entity predicts another entity or is predictive of. You see this in manufacturing. I think we'll talk to Soudip about this in segment 2 or later on in the show. But graphs, bottom line, really powerful technology, very lean, very efficient in terms of being able to generate views of relationships. And that's a big part of what discovery is all about in the world of analytics. So with that, Todd Blaschka, welcome to Inside Analysis. Tell us a bit about yourself and what you're doing at TigerGraph.
No, it's a pleasure to speak and be on your program again, Eric. My name is Todd Blaschka. I serve as the Chief Operating Officer for TigerGraph. TigerGraph is a graph analytics and database company. It has been commercially in market since 2017. It has built a engine that is designed to support big data and all the problems that come with big data. As we hear from customers, more data, more problems. The complexity of the data, the scaling of the data, the amount of data that's coming in every single day. How do you make better sense of that data and make better decisions? And so with this graph database technology that TigerGraph has developed, it is powering many decision-making systems that can support new AI applications, as well as enhanced machine learning models through new feature extractions that can support a variety of use cases. And you brought up supply chain, which is one of the ones that is a great use case in that area. One of the things, as you were talking about the truckers, there's a few things here. When I talk to companies in this particular space, they tell me that they're under relentless pressure to get better insights out of their data, and they need to know it now, and they need to make better decisions. And when you have a catastrophic event such as the trucker, the trucker blockade for the last 6 days, it creates all these questions, all these what if scenarios, and so the supply chain planners need to go look into their ERP systems, which are these big monolithic systems, to try to extract out the data to understand what are my other options? What are the scenarios? If this is blocked there for 2 weeks, how can I get the products to where they need to be? Right. And then has my demand changed? And if I don't know, and how can I model that? So many of our customers in the supply chain and manufacturing space use Graph as a what if engine to be able to run these models, because they're able to look across their business horizontally. So as you were using the example, what parts are on these trucks, and those parts are for what products in what locations.
Right.
That is all connected. So what you just talked about from the nodes and edges, that is clearly connected. Then you could take that and expand it to where the manufacturers. Do I have other options or other suppliers that can get the products to where they need to be if that continues to be a problem? And another macro issue that we face in supply chain today is the chip shortage. And how do you model the chip shortage and the prioritization of where to put the chips into what products when you have more supply available? Yeah. And then there can become these monumental changes in buyer behavior, such as COP26. That was back in the fourth quarter of this past year. That was all about better efficiencies and improving for climate. That changed buyer behavior from gas cars to electric. Now, how do I move those parts to where that new demand is and then for what electric vehicles do I put those chips in? Because I want to make sure I make those right decisions. Those decisions are multi-million-dollar decisions.
That's
if
right.
You bet wrong, how do you unwind that decision? So you need to be able to run a lot of different models on real time and changing behavior. Customer perception or interest in those particular cars may change in a matter of 1 week, in a matter of 1 day. How do you take that data and apply it? So what we're seeing is companies leveraging and using Graph as their what if engine, as their agile engine for modeling outside of their ERP systems, which are not designed, they're designed to source facts, not designed to run horizontal analysis across the organization.
That's a great point. ERP systems are designed to source facts, not do analytics. And what's interesting here is we've had lots of different ways to do analysis over the years. I kind of teased this at the top of the hour here. You'd have data warehouses, for example, which can be very useful for certain kinds of queries. But the kind of query you're talking about is very complex and frankly would be almost impossible, I think, to pull off in just a whole series of SQL. I mean, you could pull it off, I guess, but it would be pretty inefficient. So what you want to be able to do is model around the parts that you want to sell, the suppliers that you work with, the customer behavior, the market behavior that you're monitoring, that you're interested in. You build a model to understand these things, and you start doing what if scenarios to see, okay, well, what if we stop servicing this line of products and instead pivot to this line of products? What's that going to look like? All of these decisions can be then aided by good information, good analysis based upon these predictive models. But without a model, you're just kind of guessing, right, Todd?
Yeah. When you also bring up another point that's very important is, with more data, the organizations are trying to find new ways in how to store the data, whether it's storing it in relational, whether databases, whether it is storing it in lakes. And when a lake does not encompass all endpoints or all components of the data across an organization. So then what happens is whether you have a combination of lakes, they're supporting some parts of the business, and you also have other data storage that are supporting other parts of the business functions. when you are then applying ML or AI models on that, we're applying on a subset of the data of where that entity is stored. So with sampling, you get average output, and you may miss the real insights because you are not able to connect the data across the organization on that entity. You're still getting limited amount of insights because you're in some ways you're forcing yourself to do sampling, which really is not, from a data science approach, will provide you the real truth in the data. So these techniques, from new ways of storing the data and then applying AI and ML, if they're only being applied over a set of the data horizontally across the organization, because again, information on a part sits in probably 30 different data sources across the organization, from purchase to logistics to invoicing to supplier and supplier contract. You may not be able to get all that stuff into a data warehouse. It's going to be stored in multiple sources. How do you link it together across the organization so you can have the full picture from that entity's point of view, and then be able to run pattern matching and similarity analysis on that entity in connection with other data in those areas to drive better insights? So when you go back to it, as you said, the sampling is still not going to get you to where you need to be. You will still lose a competitive advantage and quite possibly miss out on significant insights that could drive significant cost savings or new revenue opportunities for the business.
Yeah, that's a really good point too. And as I'm thinking about this, and again, we teased this at the top of the hour, finding covariance, which facets, and you mentioned feature discovery. This is one that I love Graph for, because feature discovery is pretty compelling stuff. And for our audience out there, what we're talking about is looking at some massive amount of data and trying to figure out what are the meaningful facets of this data. So it could be dollar amounts of purchases. It could be the colors, if you're in the retail business, of the clothing items you want to sell. It could be distance from a certain location if you're interested in geospatial. Point being, there are lots of different bits of data that can be used that could wind up being predictive of other types of data or other types of transactions. And what Todd is explaining here is that any large business is going to have, hundreds, if not thousands of information systems. Some of them will have data that is conducive for data warehousing, but others of them will not. And if you can find some way to get all the critical bits of information into a graph, into a knowledge graph of sorts, then start doing some modeling, you have, I think, a much broader and richer tapestry, I suppose, from which to work. Would you agree with that, Todd?
Yes. And here's a couple interesting facts that really help shed light on this. The average enterprise has over 470 data products in their organization, 470. And secondly, I was talking to one Fortune 1000 company. I was talking to one of their executives the other day, and she told me that they have 57 ERP systems in their organization. 57. So and this becomes their real data challenge. How do you connect that entity and that entity from those 57 ERP systems alone to be able to run analytics? And trying to put all that data into a lake will not suffice, because those are systems of truths for those organizations. To go through a data transformation, try to move all of that from those 57 ERPs into a system, quite frankly, will not be happening. So again, a lake will not be an end-all be-all, but there will be a way that you need to connect across those 57 ERP systems alone to find what are the entities in there. And if it's based on an email address, is it based on a part number? Is it based on a particular supplier? Those are pieces of data that you need to be able to connect to run analytics, because if you're finding you have 5 different regions sourcing from the same supplier, but you didn't know it because the information is stored in different ERP systems, then if you bring that data together, you can then drive better negotiation power, because now you know how much you're spending with that supplier in all these different regions. That visibility, which sounds like it should be very at everybody's fingertips. It's not.
Right.
CFOs struggle to ask a simple business question and get that answer. How much am I spending with XYZ on these parts? Sounds like a very simple question. To get the full picture on that is an extremely arduous task, because you need to look across the data and pull it from numerous sources to be able to get the CFO that level of information.
Yeah, and what happens, and you know this from experience, I'm sure, is that when companies don't have that kind of access, when the CFO does not have that reasonable capacity to get at that information, what do? They just go with their gut instinct. They just look at some other data, and it's funny because people will always be referencing some data in their minds, even if subconsciously, to make a decision. So if the data they have is outdated or poor quality or just inaccurate, well, then you're going to have a bad scenario. But to your point, a lot of people outside the industry don't realize how hard it is to capture all that information, especially in relatively near time, right? Or relatively near real time to make decisions on. But again, if you've thought through this and you have your data collection points and you have some graph capability to do these kinds of queries, you're a lot better off. You can do the kind of scenario modeling that's going to give you peace of mind and give you a defensible position to the board, right, Todd?
Absolutely. It is the best way to be able to get to the source of truth of information because you are able to look across the business. And the gut instinct can have catastrophic effects on a business. You're looking at it, you're looking at the signals, and sometimes if when you're looking at those signals, you want to believe this is the right thing. But you know what? It can very well be a misnomer or a misalignment, because when you look deeper and you are able to run models on more data and be able to look at it in more real time, it may point to a completely different outcome on your strategy. Being able to determine if I need to ship chips to Detroit for EV vehicles, and but which EV vehicles, and then what buyers are interested in what EV vehicles. If all of a sudden the signals change and say, well, you know what, that we think that was a signal, but in fact, it is really Japan that wants EV vehicles. Their demand and their buyer persona is becoming more real. It's not just interest; it's a fact. How do I make sure I ship those? And how can I ship those parts all the way over there? And then another way, and how can I do that more effectively? Through route optimization, which again, as you mentioned, is a graph use case, is how do I optimize? How do I get parts from A to B to C with the trucks, with the drivers, so on and so forth?
That's right, folks. So we're talking here to Todd Blaschka of TigerGraph. We have Soudip Roy Chowdhury up next from Eugenie.ai. And we're talking all about graph technology and analytics, really, and how it can be used to help with supply chain. So anyone out there in supply chain business, talk to your team, find out if you're using some kind of graph technology. I strongly recommend it because it's fantastic for scenario modeling, understanding what could possibly happen, what can we possibly do about that. Don't touch that dial. We'll be right back. You're listening to Inside Analysis.
NS1 has a singular focus to deliver the best application.
All right, one down. Soudip, you ready for your close-up?
Yes, I'm good.
I love learning about this stuff, man. It's just so interesting. And boy, do we need, it's funny because, you get more technology, you need more technology because you have more technology. But boy, we're in a place now where we better have all the tools necessary to get stuff done. Because, back to that point about the board, if you can make your case to the board and say, look, here's why we made decisions X, Y, and Z. Here's all the data to back it up. Here's our scenario modeling, et cetera. Yeah, even if you fail, it's like, what are you going to do? I mean, not everyone gets it right, despite having all the right information. There are some catastrophic failures out there. The bigger they come, the harder they fall, right?
Yeah, I was at I was presenting to multiple CIOs in a bank the other day, and one of the CIOs, she raised her hand. She wasn't too familiar with graph, but she said, "Is this going to be another $25 million mistake like Hadoop for our bank?"
No.
So that's their mindset, because they invested gobs of money on something else that has just imploded.
Right.
So it's not just where they go, but they want to also protect themselves.
What an interesting story that was. I mean, if you're at IBM, I'm sure you came across the Hadoop storyline at some point, Soudip. And I watched that whole thing from start to finish. And I was pretty dubious early on. In fact, I wrote an article in a Canadian publication, actually, Techopedia, kind of questioning the whole strategy. It's like, are you guys sure about this? Because it sounds to me like it's a little bit far-fetched. And that was right before I went to the first ever Cloudera Analyst Summit. And so I show up, And one of the analyst relations people saw me and like waved and then like pointed to some other person who came over and pinned me to my table for like 90 minutes, just chatting me up on St. Patrick's Day. Right. And I'm Irish, so I'm looking for a beer. And like, this is the cocktail hour. He like just pinned me to my table. And I was trying to figure out what the hell's going on. In retrospect, I realized they had that $740 million deal about to be inked with Intel. Oh, yeah. And they were like, dude, just quarantine that guy. Treat him like the Stuxnet virus. They're Stuxnet virus, you know? So they were like, don't let him talk to anyone, because here he's questioning the whole thing. Oh, $740 million later.
Oh, yeah. Now you don't even want to use that word Hadoop. You know,
I know.
Whoever's left, Cloudera that's left, they merged with Hortonworks. They don't use that word. They just try to pivot to analytics.
I know. I've noticed that. And it's so funny because I remember it was like $740 million for, I think it was a 16% stake. And so you're like, and this is back before the valuations went through the roof. I mean, now it's like, $20 billion valuation, who cares? It's just another walk in the park here. That was a huge amount of money for, you know, a relatively small piece. And they, you know, Intel got their butts kicked on that one.
Oh, yeah. Oh, yeah. That one should be a Harvard Business Review case study.
It probably will be sooner or later, but no one wants to talk about it. It's like the war that you lost. You just don't talk about that. Just move on.
Yeah.
All right, we got 30 seconds left. I think we learned a lot in that era. I think the progress in managing distributed systems really came a long way, and that's good for everyone. So now you got a bunch of different
No, there's been some great innovation as a result. You know, there's always some roses that come out of the ashes.
That's it. I like that. I'm going to write that down. All right, stand by. Here we go.
877-477-6061. 877-477-6061. 877-477-6061.
Welcome back to Inside Analysis. Here's your host, Eric Kavanaugh.
Alrighty, folks, welcome back to Inside Analysis. Your host here, Eric Kavanaugh. We heard from Todd Blaschka of TigerGraph in the opening segment. He'll be back for the roundtables. Next up, we have Soudip Roy Chowdhury of a company called Eugenie.ai. And Soudip, tell us a bit about yourself and what you're doing in the space of analytics.
Thank you, Eric. Hope you can hear me.
Yep, hello, you sound good.
My name is Chowdhury. I'm the founder CEO of Eugenie.ai. And Eugenie, we are helping companies like manufacturing and oil and gas, like mining and others, with their journey in the analytics, like helping them in their operational decision-making journey. Well, they are having enough data now. Now they want to make sure that they drive actions using that data. And today we are talking about digital transformations. Even Todd spoke about that. You know, that's part of that process they have started like 5 years ago. Now they really want to understand, given this all data that have collected so far, how can I transform this data to drive my actions, being it driving my operations much more economically viable way, making sure my supply chain is not disrupted because some of my machines on the shop floor are not working as expected. Now, how do I drive actions so that all these aspects of manufacturing, all my operations are well covered under the analytics umbrella? So we are helping them in order to understand whether some of the machines requires special attentions, whether they're part of their overall machine, so the overall machines that they have running on the shop floor, whether part of it requires special attention, part of them it's okay to further delay the maintenance and etc., so that they can manage the operations better, reduce the cost, which is almost like 10% of their OPEX for the maintenance, at the same time increasing the overall reliability of the operations. That is one part of what we're doing. The other interesting part, which is more exciting today as we're going through exciting time, and also Todd spoke about COP26, but this is one of the major aspects that manufacturing industry, if you take a sit back and look at the overall carbon emission today in the environment and how much attributed by energy and manufacturing, it's 47%. of the
Wow.
overall emissions. And whether we like it or not, all these companies will have to reinvent themselves how to use technology to leapfrog in the newer age where they will be under the scanner of carbon audit and they need to reduce their carbon emissions. And
Yeah,
not for them, yeah.
Yeah, let's talk about the data too, because there's an interesting subtopic here of IT versus OT. And there's been a bit of a disconnect over the years. We're talking information technology versus operational technology, the machines that actually run these manufacturing plants, that build cars, that build printers, they build computers, all these different things. They have to be very precisely built and managed over time. And of course, analytics, in particular, predictive analytics, has been used in manufacturing for years because it makes sense to do so. Because you learn, for example, that if this widget breaks, then it's going to cause this other widget downstream to break too. So when you put sensors on everything, you can sense like temperatures, you can sense the integrity of the bolt, for example. There are lots of different things that you can instrument and then test. And it seems to me that you are one of the companies that's kind of helping bridge this OT IT gap to where we can have a much more analytically driven conversation around machines and what they do and how to fix them and how to design them too, right?
Yeah. So that's one of the biggest gap in the industry, which is IT-OT convergence. Now, IT speaks in the language of data information, and OT speaks in the language of operational actions. Often those actions and the data that generated by machines, there's a dissonance. And that's why, because the IT tools that you today see, this as you rightly mentioned, that this manufacturing company, they have been using technology. It's not that they are not using technology, but those technologies are built for the IT professional within the organization. Say, for example, I use some of the techniques to predict when a machine might fail. But who is going to act on that insight is the operation guy or the maintenance person, who probably is not analytically that overpowered. So how do you translate this IT data insight to a person who will finally take that information and act on it? So there is a big work that is needed here around user experience. And Eugenie is well poised to understand how to motivate, how to make the end user understand the data insight and hence drive actions. And hence what we say is it's not AI, it's not technology, but AI for user, which we call explainable AI. It's not important to tell them that this might break, why this might break, and what you should do in order to solve that problem are more important than just telling them what would break. So there's a bigger work needed here around how do you make AI, user oriented, user AI and UX coming together in order to drive adoption and hence bridging this IT-OT convergence.
Yeah, this is really interesting stuff. And when you're talking about building some of these really big machines, like building ships, for example, cars, of course, we've been talking about, it's a very expensive process. And there are so many parts that go into it. There are so many things that you can instrument. So it pays to start the process of getting those sensors everywhere. But then it's like we were talking about with Todd, you still have to build scenarios. You still have to kind of model things to understand in a larger context, what does this all mean? But one of the things that I really love about AI and how it's maturing in the last few years is the ability of some of these algorithms to surface really interesting bits of information or potential insights, let's say, that I think would have been difficult for a human to come up on his or her own. And what I'm talking about here is, recommendation engines for, which kinds of metal to use, the material science that goes into all of this, because these are all, think about the number of attributes just for a piece of metal, like at what temperature does it burn, at what temperature does it bend, at what condition does it break. All these things are somewhat known, but aggregating all that information in a meaningful way to be able to build scenarios, that's pretty complex. And I think that's probably what you and Todd are both working on. What do you think, Soudip?
Yeah, absolutely. And one of the aspects, like, as you said, so many sensors are fitted on there. There's so many variables, so many attributes of it. How do you, consider all of this and finding out scenarios and then do the what if scenario analysis. And that's why what we're doing, also building digital twin, digital replica of the physical machines into the digital world, so that you can drive those, what if scenario analysis and etc. in a non-physical world. And then if you are comfortable with that setting, then you bring that into the physical world and apply on the real world. Now, for example, we were working with one of our, one of the biggest mining company based out of Latin America. One of the problem was their whole supply chain, the process, they kind of throw away 20% of their productions. And for that recycling, they spend a lot of money. So they want to understand, how do I set the parameter of my machines so that this production losses can reduce drastically. Like physically doing all this permutation combination is kind of impossible, right, at real time. So what we did is we took all the data coming out of sensors at real time and kind of did that multi-objective optimizations at the physical world and telling them as the prescriptions or the recommendations, this is the right setup for the controllable variables. By doing so, you can improve the product yield or quality.
Right.
So that helped them to reduce 10% of the wastage, which previously was 30%, which is a great achievement for them. And now everything is autonomous in that way. Like they're just getting that recommendation, being able to set that at real time. Yeah.
That's so interesting. It goes to show you that there are 1,000 different aspects of your business that you can tackle and optimize using these technologies. And I think you were kind of hinting there too at feature discovery, right? What are the aspects of our material, of our people, of our business model that are interesting enough to examine very closely, build models around, and then make some predictions based on? And that can be a very challenging process. So the key is that you want some kind of a system that is performant. And what I mean by that is you want to have your business analysts run a query, get the results, shake their head, go, no, that's not right. Run another query, shake their head, no, let me try something else, and just keep playing around until something clicks. And the faster you can get to that sort of real-time conversation with data, as we call it, the better off you're going to be, right, Chowdhury?
Yeah, absolutely. So for example, some of the problems that you mentioned about, so that's the way it is, like permutation combinations by which they're trying to figure out what is the right setup for it. And if you have technology behind the scene which can do this permutation combination on behalf of you and at scale, like when you have 3,000 odd machines, doing this permutation combination at real time is not definitely easy. And using machine technology, you can really do it and speed it up. And that's how you add value to the whole ecosystem. And here we are talking about one side production yield, the other side, for example, energy consumption, the other side emissions, or the fugitive emissions these machines are adding to the environment. Now thinking about when you have to make a decision, considering all these different aspects, whether you like it or not, you got to take all this into considerations. So it is extremely complex to, human, taking human, using just data and visualization, making those decisions. And hence we see AI is going to be the game changer. And that's why we are so excited here. And with technology now, big data and AI, we can solve that problem at real time. Yeah.
And if you instrument these environments, that's when you can start pulling all sorts of interesting data points together and really understanding covariance, really understanding how the big picture all comes together. And, again, what kind of gets me excited about the AI component of all this is that those algorithms can run all night long. How much ever compute you want to throw at them, whatever cost you allocate to running those algorithms, that is going to bring some value to you. And what I like about it is it shepherds the user along a little bit. So the analyst is there just looking at this mountain of information, trying to figure out, what can I solve? You obviously have to have a thing you're trying to solve, like let's reduce the amount that we throw away. Let's reduce our waste, for example. Let's reduce our emissions, whatever the case may be. You then reverse engineer and look at all the different factors that come into that. That's an exciting process. But if you have an AI in the background that's just suggesting things to you, why don't you look at this data set? Why don't you look at that data set? I find that to be incredibly compelling because a human being is always going to have bias. Like every human being has bias, not least of which about ourselves, right? We don't want to admit our weaknesses or our flaws, or it's difficult to do that. So if you have a machine, just the cold, unblinking eye, basically, of the algorithm kind of helping you along, I think that really facilitates the whole process. What do you think?
Absolutely. That's what we call augmented analytics, right? Where your AI is your sidekick, finally the human on the shop floor making the decision, but give him or her enough tool and evidence basis which she can make the right decision. So that's where it is, where I think technology are going to play a very important role coming forward. And
AI is your sidekick. I love it.
and then see, look how things are changing, right? So even human is trying to find out, like, folks on the shop floor now asking for, like, give me more, because I'm bored with what I've been doing for so many years. Like,
right.
What's my growth? And this is the growth, right? Where say, for example, how Todd was talking about the information bringing all together. Now, how we are helping is telling them if there is an incident or that there is a probability of failure of a machine, that making the decision maker aware of the fact when similar incident happened in the past, who's resolved it, how they resolved it. Like, even that connections with the person who had the knowledge about how to solve it can help their doing the job much more easier than what they would have done it by themselves, right? As a group,
right.
As a community, how do you learn from each other and do things better? I think those are very, very exciting aspects of work that's changing, and we are running, that as one of the lever for making this industry transform newer.
Yeah, that's an excellent point, frankly. I think we should pick that up in the roundtable discussion. So Soudip is mentioning collaboration around data, around problem solving. Again, if you have an information system that pulls in all this data, we've talked to Todd about the graph, Soudip about their technology. If you have systems that foster collaboration, you can do recommendations not just on next best action for your consumer who might want to buy something, but make recommendations about who should talk to whom inside your organization, which can be ascertained from, again, an unblinking eye of a machine just by noticing, this person has figured out these kinds of problems before, this person is having that problem, ping, like a Slack channel, get a little message that says, ping, contact Jeff in finance and ask him about this question. A lot of times that can be very compelling. And especially if you're talking about troubleshooting, solving for problems or challenges in the business, if you're not on the right path, man, you can spend hours, days, weeks. You could just spend the rest of your life trying to solve a problem that could have been solved in 5 seconds had you just spoken to the right person. That's what we're talking about with AI augmenting analytics. Well, folks, we're talking to Soudip Roy Chowdhury of Eugenie.ai and Todd Blaschka of TigerGraph. Will be back for the roundtables next.
NS1 has a singular focus to deliver the best application traffic, intelligence, and automation technologies.
All right, 2 down, 2 short ones to go. These are going to fly by. I'll throw the collaboration thing at you, Todd, to start us off, and let's just kind of riff off that, I guess, huh?
Yeah.
You're on mute.
That works for me. I'm easy.
Okay, cool. So what is your background? Is that a place near your house or something, or what is that?
It's Hyde Park. I actually forgot to change it. Yeah, I had meetings with our team in Europe this morning, and so kind of play around. So this was Hyde Park. I was talking to a team in Europe, or actually in the UK. So I just was playing around, put that in the background, and I totally forgot when we started this thing, and so I wasn't going to change the background mid recording. I thought that would be kind of goofy.
That's a Hyde Park in Austin?
No, Hyde Park in London.
Oh, where is it?
London, UK.
Oh, okay.
Yes.
Yeah, there's a Hyde Park in Austin too. I was like, oh, is that Austin? I'm like looking at the trains.
I didn't realize Austin had a Hyde Park.
Yeah, Hyde Park. It's a really great. It's like the best neighborhood in Austin. It's basically, if you know Austin, if you go on Congress, you cross the river or the lake, I guess it is there, and heading south, that whole area to your left is all Hyde Park, I think.
Okay.
So back behind, like, in SoCo, as they call it in Austin. I love Austin. I've lived in Austin for years, and I want to be back there, especially in the winter when in places like Pittsburgh, it gets cold.
Cold. Yes, but Texas has had a few cold, snowy times in the last couple of years.
I know. You know, I have all these far-fetched theories. I sit around and ponder this stuff all the time. But, with respect to the freeze in Texas, and I would love to see if someone at a big university would look into this, because it's a massive data problem, basically. But look what happened with COVID in like March of 2020. What happened? Everyone stopped. Like no one was flying. They cut back like 95% of the flights. People stopped driving. And there was like a 3-month period. You talked about emissions, Soudip. I'd be curious to hear your thoughts on this. You had a dramatic shift in CO2 emissions, and it went way down. I've heard 30% is the number. So it's like, well, that's interesting. You figure this, the weather patterns change over the course of a year, right? Because that's how long it takes the Earth to go all the way around the sun. It kind of wobbles as it does it. So we have different patterns, et cetera. But there's clearly an annual pattern to weather systems. And I wondered to myself, did we kind of cause that disruption? Because if you think about it, if you suck all that CO2 out of the system that you would have put in, well, we're saying there's going to be an impact on the weather, right? On the weather systems and all that fun stuff. And it's like, I think that happened. I think we froze Texas by everyone stopping moving for 3 months. But who knows? It'd be impossible to prove.
Those become a lot of different modeling, and,
right.
And when you look at it, all these things can become graph-shaped problems because you're trying to pull data from so many different sources to see what the patterns are.
Right.
And, I don't know if you noticed, but last week we just announced a global challenge, and basically a very big hackathon which we dubbed the $1 Million Challenge. So the company's giving away $1 million to teams and individuals that come up with innovative ways to use graph technology. And some of the ideas are how to make the world a better place, whether you're looking at climate change or better ways to take care of medical issues. So part of it is to help.
All right, here we go. We're back.
All right.
I'll let you tease that in the last break.
That's 800-245-1375. 800-245-1375.
Welcome back to Inside Analysis. Here's your host, Eric Kavanaugh.
All right, folks, welcome back once again to Inside Analysis, talking all about analytics and the information economy. We talked to Todd Blaschka in the opening segment, then Soudip Roy Chowdhury in the second segment. Now it's time for the roundtable. And I want to talk about collaboration, and then we'll tease an interesting program that TigerGraph has coming out now as well, $1 Million Challenge. But I'll throw it over to Todd first. Collaboration is the name of the game. I mean, collaboration can change everything and anything when you do it correctly. I often reference Google Docs and what an amazing job they did at allowing you to be able to have 2, 3, 5, 10 people working on the same document at the same time. I'm like, wow, how did Microsoft not figure that out first? Well, I don't know. But Google did a pretty good job with it. And it just, in the editorial world, as simple a job as that is, just having a document that you agree to, you have to send it on email to this person, that person. I used to work in an ad agency, and like everyone would mark up the print in their own scribbly handwriting. And I'm like, this is not going to work. This process is going to change today, and I'm going to change it because we can't live like this. So collaboration can be great if you do it properly. And now there's a million ways to do it, right? So in our space in particular, collaboration is the key. Don't you think so, Todd?
Oh, absolutely. And as you're talking about that, and as I heard Soudip talk about it from Eugenie's perspective, one of the things I hear from customers as I talk to them about their machine learning and their data science programs, one company that comes to my mind is they have over 3,000 data scientists. Think about the amount of money on salaries alone for 3,000 data scientists.
Wow.
I asked one of the leaders, how many products have gone into production? He said, I could count them on one hand. Wow. Think about the ROI. I said, well, what is the problem? 80% of the time, the data scientists are trying to get data to work with. So just trying to get data to work with. And then what do? They set up their own silo of their data to work on their data. So, and so then that's not talking. So one data scientist has an output that goes to another one, and then you have data moving in and out. It's not efficient. And so by being able to have data where it could be collaboration, where multiple users can work off the same set of data and then benefit when the data changes to update their systems and models. That intelligence can drive so much more productivity and efficiency. And I'm very curious, from Soudip's point of view, because that goes into one of the big messages he's talking about, the value of what they're doing. So I'd love to hear what your point of view, Soudip.
Yeah, thank you, Todd. Productivity is a big issue. I'll tell you, this is my experience. I was working with one of the biggest oil and gas in the US. And one of the questions that I had asked, like when you have this issues, right? What is the typical resolution time, median, right? Just give me a median time. He said 7 days, like 6 to 7 days, any issues? How many people on the floor, got impact? I mean, will be sitting idle if something is not found out? Like around 1,000 employees. Now think about the cost that you are losing because of the fact that no one is able to find a resolution. And said, is this this problem, if you pick up, is it the first time that is happening? Is it unique in that nature? The answer is no. Then why did you spend 7 days? Like you have been running this operation for hundreds of years.
Right.
Like only the question is, managing these people, knowing exactly who knows what, and then just making that connection. That's it. Like you don't need to boil the ocean. Like this could be a very simple solution, but it's very hard for a big enterprise. This knowledge are sitting siloed somewhere. No one has information, or people do not know how to collaborate given the context, given the current problem. And that's a challenge, and that's we got to realize that it's not easy, but how to build a smart solution. Like for example, in your case, the collab, the Google solution and solve the problem, right? How different data scientists will collaborate on a piece of code and then solve together. And that's the way we are moving towards, where it's not yet another noise in the world, but let's work together to add value together. So that's where I think the next generation innovation will come.
That's a good point. And Todd, I'll bring you back in. As Soudip was talking there, I couldn't help but think about graph technology. It was probably 10 years ago. I was talking to a vendor about their graph technology and what they're doing with it. And I realized that it's such a powerful technology for being able to pull together bits and pieces from different systems, right? The problem you have with the relational database and a data warehouse is that all that data has to be of a certain form. It has to really fit in the little slots where it's supposed to. Then you could start to get some value. But lots of information systems are not that wieldy, I guess. They tend to be rather unwieldy. And so it helps to be able to just pull the useful bits of information and persist them in a knowledge graph. Like in a customer service center, for example, one of the use cases was that they were having difficulty getting all the data from the different systems into some repository that they could then feed to a customer service rep who, let's face it, has to know pretty darn fast what's going on, like within a second to 5 seconds. If they're waiting longer than that, then you have a very angry person on the phone. So that's an interesting situation where the power of graph can deliver up all sorts of useful bits. This person was just on the website. They called in yesterday or yesterday afternoon or something. It's a high value customer. Now you've got some good intelligence to know, hey, let's take care of this person, right, Todd?
Oh, 100%. I mean, what you're bringing up is there's one of the key differences when it goes back to the engine of how data is stored. Relational stores it as facts, and storing the facts are important. But what's the context? How important is it? And if you have facts stored about a customer in 30 different systems, how do you link them together? Because being able to link it together and then run analytics, you can provide better contextual recommendations and better contextual next best actions. And that could drive better customer experience through the roof. It becomes a strong competitive differentiator, being able to link and store that data. The second thing is with graph is the ease of which you can add attributes. Like you said, you want to bring in another data source. There may be only 2 or 3 columns you want to bring in. It is what's called a flexible schema, which means how your model is flexible. You can easily add attributes. In a relational database, schema changes are, drive database administration crazy. It is extremely costly, very expensive to take a lot of time to update a schema. With graph technology, it's flexible, it's super easy to add updates, so you can get new insights with new attributes you want to add about that entity, about that person, as an example. All of a sudden, they add a new address. Why is there a new address? Is this a second home? Can that trigger how I want to communicate to them or what I want to offer them? You cannot do that easily in a relational system.
Yeah, and that's really important. Flexibility. I think you look at the information economy. Soudip, I'll throw it over to you for closing comments here. Agility is imperative in today's business world. We're seeing that with supply chains right now. Who would have thought? I mean, if you asked me 2.5 years ago, would a whole bunch of truckers blockade the border between the U.S. and Canada, I'd be like, what are you talking about? Does the end of the world happen? What's going on here? You never know what's going to happen. Crazy things can happen. So if you have agility, if you have the information, if you have the data, if you know your priorities, and you have some kind of abstract environment in which you can do your scenario modeling, and there's that term again, you're going to be a lot better off, because even like the old Eisenhower quote, I've always found that plans are useless, but planning is indispensable. But Soudip, what do you think about that?
Yeah, I think you're right on that point, right? So agility is very important, but how do you achieve that agility? What we think is the interesting fact is, if you see the world as connected world, like if it's not any industry, any vertical existing in silos, right? All of these are connected, like how Todd mentioned about using graph to connect all this information, but connecting all this and then finding out smarter way by which you can find out relationship and find out if something is blocked, how to find a way around it.
Right.
And that's how I think we see the world, how it's going to transform.
Yeah.
And yeah, using AI and technology, probably we can do it at scale, and that's the beauty of using technology.
Yeah, that's exactly right. And I will say the human will always be in the loop. Folks, don't worry about the human being cut out of the loop. No matter how powerful your AI is, there are always going to be human beings with their hands on the controls, at least hopefully, because otherwise things could go terribly, dreadfully wrong. And we've seen that in the world of business. But that human in the loop, and human beings are very good problem solvers, right? Because no matter how well you train an algorithm, you're going to miss things. You can't just bake the entire world of knowledge into a single algorithm. That's never, ever going to happen. And human beings are very creative creatures. We can come up with ideas that are outside the box, let's say, new ways of doing things. But the key is to have the information, to have the insight, to be able to leverage when making decisions, and then to have an apparatus through which you can effect change, through which you can do things differently, and have that not be a completely manual process. The more automated you are, the better off you're going to fare in this modern information economy, folks. Look these gentlemen up online, Soudip Roy Chowdhury of Eugenie.ai and Todd Blaschka of TigerGraph. Podcast bonus segment is coming up next. You're listening to Inside Analysis.
In the know, I'm Mariah Haberman.
All right, guys. I want to do a quick 8 minutes.